The US Department of Energy right now publishes official guides telling Americans to build earth-sheltered homes, promising 80 to 90% low heating and cooling bills. Isn't provincial. What they do not tell you is that the Mandan people of North Dakota already cracked this exact problem in 1500. And they did it so well that their homes stayed livable at 40 degrees below zero. Not 40 degrees, 40 below zero. Either. The kind of cold that freezes your breath before it leaves your mouth. The kind of cold that kills horses left outside overnight. And inside these structures, no furnace, no insulation wrapped in plastic, no double pane windows. It was warm enough to sleep. Warm enough to live. And moisture isn't safe either. Warm enough that an artist named George Catlin visited in 1832 and wrote it down because he could not believe it himself. That is not magic. That is engineering. Specifically, invites. It is some of the most sophisticated, passive thermal engineering ever built in North America. And most people have never heard a single word about it. Here is what we are going to cover. In SAWSAD, we are going to walk through exactly how an earth lodge worked, the physics, the geometry, the materials, the hidden systems most historians skip right over. We are going to talk about horses as heaters. We are going to talk about a hole in the roof that simultaneously solved two completely opposite problems in Dan, depending on the season. And sci-fi. And we are going to talk about the moment in history when this architecture was born. Because that timing is not a coincidence. Either. And it tells us something important about how humans respond when the climate turns on them. Because people consistently underestimate these structures, but consistently underestimate the structure. The average Mandan Hidatsa or Arikara Earth Lodge was 35 to 45 feet in diameter. The largest ones pushed 65 feet across. To put that in terms you can picture, Siemens Interior. A 40-foot diameter circular floor plan gives you roughly 1,250 square feet of usable interior. Hansi and Piniji-Dad. A 45-foot lodge hits close to 1,590 square feet. The biggest ones at 65 feet? Nearly 3,300 square feet. Either. The median new American home, built in 2023, is about 2,300 square feet. These lodges were not cramped survival shelters. They were large, deliberately designed communal homes that housed 8 to 60 people. Either. Multiple generations of a family living together under one roof. Entire villages of 100 or more lodges held thousands of people. An urban settlement, not a camp. And al pred exaficamitidiel. Now let's talk about how genius starts, because the construction process is where the thermal genius starts. The first thing a crew did was excavate. They dug the floor down, not on top of the ground, but into it. Either. Anywhere from 12 to 24 inches below grade. That sounds like a small detail. It is not. The below-grade construction is one of the most powerful passive thermal strategies in existence because the ground itself becomes your insulator. Deep ground temperature in Montana and the Dakota sits at roughly 45 degrees Fahrenheit year-round. Winter, summer, blizzard, heat wave, 45 degrees. The Earth does not care what the air above it is doing. So the moment you sink your floor 18 inches into the ground, every wall, every surface close to that floor is constantly being pulled toward 45 degrees. Not heated or cooled by a machine stabilized by the planet. From that excavated pit, 4 massive cottonwood posts went up at the center. These were not small timbers, in part. Seekin vegan, lateral bathing injunctions hauled to the site and set in a square pattern roughly 10 feet apart. Horizontal beams connected them at the top, forming the primary load-bearing ring. Then, from a perimeter ring of shorter posts set further out, 75 to 100 rafter poles extended upward and inward like the spokes of an enormous wheel, all converging at a single point at the apex, a smoke hole about 3 feet across, open to the sky. That smoke hole is going to come back in a major way. Hold on to it. The Pawnee, building their own version of the Earth Lodge to the south, sometimes used 4, 8, or even 12 center posts instead of 4. And here is a detail that reveals something about the precision of this tradition. Pawnee builders did not cut joinery into their posts. They selected trees that naturally forked in a Y shape at the right height, and used that fork as a cradle for the horizontal beams. In Tamils 4, they were engineering their lumber selection before the timber even arrived on site. Once the frame was up, the roofing began. Willow branches were lashed across the rafter poles in a dense lattice. Over the willow went thick mats of prairie grass. Over the grass went sod, blocks of intact prairie earth, root side down, stacked and packed. And over all of that went more packed earth. By the time the roof was finished, it was 2 to 3 feet of solid earth sitting on top of a woven structural base, not a few inches of sod. To 3 feet and pulled even sari fat, enough that you could walk on it, and enough that the thermal mass of that roof was doing serious work. Here is what thermal mass actually means in practice. Materials with high thermal mass, earth, stone, adobe, concrete, absorb heat slowly and release it slowly. When outside temperature surges crash at night, the mass keeps radiating stored heat into the interior. When outside temperatures spike during the day, the mass absorbs that heat before it can reach the living space. The thicker the mass, the longer the lag. A 2-foot packed earth roof does not just insulate, it creates a time delay. Nach cold German and Acid Promil, the cold of a North Dakota January night, might be pressing down on the outside of that roof all night long, but the interior is still releasing heat that was stored hours earlier. And that is before the snow. When snow fell on a Mandan village, it accumulated on the domes. And it stayed there. No one climbed up to shovel it off. Because snow is an extraordinary insulator, the same reason an igloo works. Snow is roughly 90 to 95% trapped air by volume. Air does not conduct heat. A foot of snow sitting on top of 2 feet of packed earth is not a problem. It is a bonus layer. The lodge under a foot of accumulated snow was more thermally protected than the lodge without it. Not passive acceptance of winter, a design that made winter work for you. Now we need to talk about the entrance. And this is the detail that tends to stop people cold, no pun intended. You did not walk straight from outside air directly into an earth lodge. The entrance was a tunnel, 6 to 15 feet long, lower than the main floor, and angled away from the prevailing wind. To get inside, you stepped down into this tunnel, moved through it, and came up into the interior. Why does that matter? Because cold air is dense. Dense air sinks. But too little moisture isn't a safe tower to a containing pouring the climb, Ted, that dips below the level of the living space. It literally cannot make the climb. It pools at the lowest point of the tunnel and stops there. The living space stays protected. Builders called it a cold trap. And runs the bidynamic principle. It runs on the same thermodynamic entries you see on every well-designed cold climate building today. The double-door entry systems in airports, hospitals, and motordyne cold climate homes that prevent the interior from being blasted with outside air every time a door opens. The Tess the Mandan were building atom cold traps into their homes around 1500. Modern architects rediscovered the principle and called it best practice. The angle mattered too. Ekdanding full moision damdas. Termitrum, bowing wind, meant the tunnel entrance was physically sheltered, not just thermodynamically protected. The seeds extending the damen colder, call, but shielded from the Constanescrin trying to push its way in. And now the smoke hole. Picture the dome from outside. Wind passes over the curved surface of the lodge. And seeds accelerates that wind, and when it hits the apex, the highest point, it creates something. Negative pressure. A partial vacuum. The same principle that generates lift under an airplane wing. That negative pressure at the smoke hole does not just let smoke out, it actively pulls smoke out. A suction effect built into the geometry of the structure. Meanwhile, the fire at the center of the lodge is driving a stack effect. Hot air rises, feeds into the drafting column above the fire, and pulls more air in from behind and below. The tunnel entrance becomes the fresh air intake. Cold air is drawn through the tunnel, warmed as it crosses the floor toward the fire, rises with the smoke, and exits through the hole at the top. It's section of daft to begin the dried danding anytains from the gene. Bernoulli ekdekt molden shape and stack effect from the fire working together, reinforcing each other. The lodge was not just warm in winter. It was actively ventilated. Now here is the thing almost nobody talks about. In summer, flip the picture. There is no fire. The floor and lower walls are sitting at 45 degrees because the ground never changed. The air at the top of the dome, close to the smoke hole, is warmer. Warm air rises. It moves up and out through the smoke hole. That draws cooler air in through the shaded tunnel entrance. The lodge runs as a passive cooling system. Cool air in from below, warm air exhausted from above. The same hole that vented combustion gases in January was ventilating heat in July. One feature, two opposite seasonal functions, zero moving parts. George Catlin was not exaggerating in 1832. He was describing physics. Nulpeler tens day and drine ein flare. Let's tell moisture descension began, because this is the part of the story that tends to reframe everything. That bekansing and degultitwide. Earth lodges in the archaeological record of central North Dakota and South Dakota around 1500. That is not an arbitrary date. That date lines up directly with the end of the Little Ice Age, specifically the period climatologists call the Neoboreal. A cumulative moisture is industry when average temperatures dropped significantly across the northern hemisphere. Crops failed. Winters extended. The baseline cold got worse. The architectural response was immediate and documentable. Lodges built after 1500 show measurably thicker walls, deeper subterranean foundations, and heavier earthen roofs than the structures that came before them. No gradual drift. No coincidence. Pure engineering, adaptation, a population facing a climate shift, and rebuilding their homes in direct response. The Mandan and Hidatsa did not wait for a government report. Das Tijday, they built their way through a climate emergency, using the best thermal science available, which happened to be dirt, wood, and 400 years of accumulated knowledge. These lodges remained in Oskay in continuous use from around 1500, all the way to the late 1800s. Classium either, nearly 400 years of the same basic design, not because no one thought to update it, but because it worked. Aden, a cottonwood-framed earth lodge needed full reconstruction every 7 to 10 years. Since Cottonwood is a relatively soft wood that degrades. But the reconstruction happened communally. A full lodge built in roughly 7 to 10 days by the entire village working together. The investment was worth repeating over and over for nearly 4 centuries. Now we get to the thing that is genuinely underappreciated: the horses. The Plains tribes kept horses. Everyone knows that. What most people do not know is that in winter, the family's most valuable horses, the war horses, the hunting horses, the animals that represented wealth and survival, were brought inside the lodge at night, not into a separate barn, into the living space near the entrance. A single horse produces between 1,000 and 2,000 BTUs of body heat per hour. Continuous, reliable, metabolic heat, no combustion required, no wood gathered, no fire tended. Multiple horsebite isbulger knife, indoors on a brutal January night, were running as a biomass heating system. They kept themselves alive by staying warm, and in doing so, they kept the people warm too. The horses got shelter. The people got the heat the horses threw off. Either a mutual arrangement baked into the cultural practice of where you kept your animals. Nobody in 1500 had the vocabulary for passive biomass heating, but that is exactly what it was. But the thermal benefit was real, it was measurable, and it was built into the daily rhythm of winter life in a Mandan village. Not a metaphor. Heat transfer. And then there is the floor. Scattered across the floor of an earth lodge were cache pits, bell-shaped holes dug straight down through the floor, narrow at the top, flaring out to 3 to 5 feet wide at the base scanned, and reaching 5 to 8 feet deep. They were sealed with a cover when not in use. In winter, those pits descended below the frost line, the level where ground temperature stabilizes and freezing stops. Food stored there would not freeze. In summer, those same pits were surrounded by earth, sitting at 45 degrees. Natural refrigerators, built directly into the floor of the home, powered by the same thermal demass that insulated the walls. No electricity. No ice delivered by the pound. No mechanical refrigeration of any kind. Just a hole in the ground, in exactly the right place, at exactly the right depth. The same engineering principle doing 3 jobs at once: insulating the structure, preserving the food supply, and stabilizing the indoor climate. Knife River, Indian Village's National Historic Site in North Dakota, maintained by the National Park Service, reconstructed a full-scale Hidatsa Earth Lodge in 1995. You can visit it today. It's safe uther. The archaeological depressions of the original lodges are visible across the landscape. Some assured mitre isn't see mited light to pre-mundans, up to 40 feet in diameter and 14 feet tall, just sitting there in the earth like pressed thumbprints in dawn, marking the outlines of homes that housed thousands of people across 4 centuries. Batir Bachir the Rashu, yet at the edge of one of those depressions, and you are standing at the rim of what was once a fully climate-controlled living space. Here is the takeaway, and I want to be direct about it. The U.S. As Edelby and ID, Department of Energy recommends earth-sheltered passive homes today because the thermal physics are undeniable. Semi-subterranean construction, thermal mass walls, cold trap entryways, passive ventilation through strategic apertures, but cool than standard safe tier. All of it contained in 90% cheaper and TNT, and cool than standard above-ground construction. The physics have not changed. The Earth's ground temperature has not changed. What changed is that we forgot this knowledge existed, spent 150 years building thin-walled houses on slabs, and are now rediscovering the principles as if they are new. They are not new. Invisig into North America. In the Dakotas before the first European colonial settlements appeared in North America. Adobe walls in Pueblo construction, 16 to 24 inches thick, keep interiors at no hotter than 80 degrees Fahrenheit, in regions where outside temperatures hit 95 and above. Aesir. They hold at no colder than 65 degrees Fahrenheit in winter, with daily temperature swings 40% lower than wood frame construction. The passive thermal performance of indigenous North American architecture is not folk wisdom. It is empirically verified materials, science applied at scale, over generations, refined by people who had direct feedback in the form of survival. The most sophisticated passive building system in the history of North America was not designed in a laboratory, but it was designed on the northern plains by communities facing a climate shift, either using the ground beneath their feet and the physics of moving air. And most people have never heard a word about it. So here is what I want to know from you. If you had to build a home right now, using only the principles we just covered, thermal mass, semi-subterranean foundation, passive ventilation, cold trap entry, wow, what would you change about the house you currently live in? Drop that in the comments. I am genuinely curious, and I read every single one. If this hit different than you expected, hit the like button and share it with someone who thinks ancient architecture was primitive. Because what we just covered was not primitive. It was solved. And if you are not subscribed yet, fix that now. Because next time, we are looking at another engineering system that modern builders are only starting to catch up to, and it is going to make this one look like a warm-up.